All right, let's talk about the one skill that really, truly separates a good developer from a great one: mastering the hunt for bugs in Java. Our goal today is to take that sinking feeling you get when an app crashes and turn it into the confidence of a seasoned problem solver. So let's dive in.
You know the feeling. We've all been there. Your code compiles just fine, it starts to run, and then bam, it crashes, or it freezes, or it just gives you some bizarre output, and you're just staring at the screen and your mind goes blank, right? That moment, that's what we're going to change today.
So here's our game plan. First, we'll talk about why bugs are just a fact of life. Then, we're going to get hands-on with the essential toolkit every Java dev needs. After that, we'll go hunting for some really tricky bugs, then shift gears to learn how to code defensively so we have fewer bugs to begin with. And finally, we'll talk about building the right mindset to make you a debugging master.
Okay, first things first. Every single developer writes bugs. I write bugs, you write bugs, we all do. The secret isn't to never make mistakes, it's to get incredibly good at finding them. And that starts by leaving some old habits behind and picking up some way more powerful techniques.
Look, a lot of us start out just sprinkling system.out.println everywhere to see what's going on. And hey, for a quick sanity check, it's not the worst thing. But let's be real. It clutters up your code, it floods your console, and you have to recompile every single time you add or remove one. A real debugger, on the other hand, that's a total game changer. It's like having a superpower to pause time inside your running application, look around, and see exactly what your code is thinking.
So, what is debugging at its core? It's not just random guessing, it's a methodical investigation. You're not just staring at the error message after the fact, you are literally pausing the program in the middle of the action to inspect its state. You get to be a detective, gathering clues right from the scene of the crime.
All right, enough theory. Let's get our hands dirty. Modern IDEs like IntelliJ or Eclipse have these phenomenal debugging tools baked right in. We're about to master the fundamental workflow that you are going to use day in and day out. This is your bread and butter, the rhythm of debugging. First, you set a breakpoint. Think of it as a little red stop sign for your code. Then, you launch your application in debug mode. When the code execution hits that stop sign, everything pauses. From there, you can step through your code line by painful line and inspect your variables to see exactly where things went wrong.
Now, stepping through code gives you an amazing amount of control. It's not just one action. You can step over a line if you're pretty sure a method call is working fine and you don't care about the details. Or you can step into that method to dive deep and see what's happening inside. And if you find yourself too deep in the rabbit hole, you just step out to pop right back to where you were. Mastering these three moves is absolutely key to debugging efficiently.
Okay, you ready for a pro-level trick that will save you hours of your life? Imagine a bug only happens inside a loop, but only on like the 5,000th iteration. You're not going to sit there and click the step button 5,000 times. That's where conditional breakpoints come in. You tell the debugger, hey, only pause on this line if this specific condition is true, like when a variable finally hits a certain value. It is an incredible time saver.
So that basic debugging loop is fantastic for your everyday logic errors. But what about those really weird ghost-in-the-machine type bugs? You know the ones, where your application just slows to a crawl, or it freezes up completely, or it just eats all your memory. For those, we need to bring out the big guns. See, when you're dealing with an out-of-memory error, or your app is just completely frozen, pausing on a single line of code usually doesn't help. The problem isn't one line, it's something systemic. We need a much bigger picture. We need a complete snapshot of the entire Java virtual machine, the world your code actually lives in.
The first kind of snapshot is called a heap dump. Imagine you could literally take an X-ray of your application's memory at one exact moment. That's a heap dump. It shows you every single object that exists. It's your #1 weapon against memory leaks, and you can even tell the JVM to create one automatically right when it runs out of memory.
The second snapshot is a thread dump. If you think of threads as all the individual workers doing tasks inside your application, a thread dump is like taking a photograph of every single worker at the exact same instant. It tells you what each one was doing. Is one of them stuck in a loop? Are two of them waiting on each other forever in a deadlock? A thread dump reveals all of that.
And this little table makes it really simple. If you see an out-of-memory error, you need a heap dump. If your application is frozen solid, your CPU is pegged at 100%, or you suspect a deadlock, you grab a thread dump. It really is that straightforward.
Now, these dump files aren't something you can just open in a text editor. They're massive binary files. You need a special tool to make sense of them. Things like Eclipse Mat, Visual VM, or JProfiler are designed to parse these files and give you reports that can point you right to the root cause of the problem.
So far, we've been playing detective, right? Chasing down clues after a bug has already happened. But what if we could prevent the crime from happening in the first place? That's the whole idea behind defensive programming. It's all about anticipating problems before they ever become bugs.
And a huge part of that is really understanding how Java handles exceptions. Checked exceptions, like an I/O exception, are for external problems you can't control, like a network failure. The compiler forces you to handle them. But unchecked exceptions, like the infamous null pointer exception, those represent bugs in your own logic. They're mistakes that should be fixed, not just caught. Knowing that difference is crucial for writing clean, robust code.
And speaking of preventing problems, here is one of the best defensive moves in modern Java. It solves a classic, nasty bug, forgetting to close things like files or database connections. The try with resources statement handles all that cleanup for you, automatically. No more leaks, it just works.
And this isn't just about writing tidy code. The benefits are massive. You prevent resource leaks that can bring down your entire application. You actually improve security by making it harder for someone to launch a resource exhaustion attack. And it just makes your code way cleaner and safer. So we've talked about tools, we've talked about techniques, but the most powerful debugging tool you have isn't in your IDE. It's right there between your ears. It's about how you approach problems with a curious, disciplined mindset.
Which brings me to a technique that sounds, well, it sounds kind of silly, but I promise you it is shockingly effective. It's called rubber duck debugging. The idea is simple. You explain your code, line by line, out loud, to an inanimate object, like a rubber duck on your desk. The simple act of articulating what you think the code is doing forces you to slow down. And so often you'll hear yourself say something that just doesn't make sense, and boom, you've found the bug.
And that really gets to the heart of it, doesn't it? A bug isn't just a mistake you fix and then forget about. A bug is a lesson. It's your code trying to tell you something. It reveals a flawed assumption you had, a hidden complexity you missed, or a weakness in your overall design. So the next time you squash a bug, don't just celebrate and move on. Stop and ask yourself, what did this teach me? Because answering that question is how you truly master the hunt.